Hi, and welcome to our team's year-long project with Providence St. Joseph Health. To start off with, I want to introduce the team. From left to right, we have myself, Harbin, who will take you through the dashboard, Patrick, who will take you through our predictive model that we created for Providence, and we're going to conclude with Shilpa, who will go into summary points and recommendations for the company itself. So I wanted to start off by briefly talking about Providence St. Joseph Health itself. This company is a nonprofit Catholic healthcare group with over 50 hospitals and over 800 clinics operating in 7 states, including Washington State itself. On the side, Providence is highly involved in the advocating for vulnerable populations while also providing high quality healthcare to people located in those 7 states. So to start off with the problem that Providence proposed to us in June of last year, the Internal Services and Technology Department, otherwise known as the IS Department, wanted to improve internal customer satisfaction. And this is in a metric that all companies, regardless of industry, actively try to work towards. A couple ideas that seem relatively prominent across the industry, and not just in Providence, stood out to us as maybe a probable reason as to why perhaps customer service or customer satisfaction was a little bit decreased. And that included elongated wait times for the tickets or maybe too many systems to learn within the company itself. Providence leadership was utilizing at the time survey analytics to figure out the issue, and this was a huge part that the client needed help on. So within the project, our team engaged in several steps in order to solve this issue. Um, we started off with identifying areas of improvement, and then we followed with deep diving into service ticket data and all the data that we were provided to come to conclusions on optimization. And then we utilized a number of tools to help us do this, including Azure Machine Learning Studio and several data visualization software such as Tableau or Power BI. So now I'll briefly run through all of the 4 stages or the 4 phases that took place throughout the project. So phase 1, as you can see here, consisted mainly of survey analytics. And as mentioned before, Providence was engaged in the use of a company-wide survey to understand satisfaction with the IS department. So an executive survey was given to all the execs in the company. And from those survey results, we deduced a mean sentiment score that was the main metric for usage. 2 important questions that were asked provided mean scores as well. The first one was, how would you rate your service on a scale of 1 to 5? Well, the second question was, do you feel that IT understands your business? And from these survey responses, we were able to deduce main points of improvement. The next stage was to deploy a caregiver survey, which would go out enterprise-wide. And in this case, caregiver refers to employees of Providence. However, in phase 2, the timeline of the surveys changed, and as you can imagine, this project scope and the focus changed with it. From here, our team took the opportunity to wrap service ticket data into the analysis, and we proposed improving and optimizing the service ticket process. We ended up obtaining the necessary data that we needed and began data exploration, cleaning, transformation, and analysis, where we focused on variables that could be or are impactful to the time it took to resolve a ticket. Now, in phase 3, we moved on to utilizing Azure Machine Learning to create a predictive model to essentially predict how long it would take to resolve a ticket. And that was based on the historical data that we were provided. Within this phase, we built out the model and trained it, tested it, and created a dashboard in both Tableau and Power BI with our results. The model and dashboards will be talked through and shown by my teammates in a few minutes, where they'll go a little bit more in depth about what we created and found. Now in phase 4, and this is the final phase, we deployed the model. And created a highly visual and intuitive heat map representing key points of concern for Providence, and that was based off a location. We presented all of this to the leadership, who received it in a well manner and resulted in an ask of step-by-step and highly detailed documentation in order for the company to successfully implement it into their internal framework. Now, that was just a quick overview of our project and what steps were taken to solve Providence's issue. Now I'll pass it over to my team member, Harbin, who will take you through the Power BI dashboard that talks about KPIs and the heat map itself.
Thanks, Renee. Now I'll be going over a high-level overview of the pages we created for our dashboard. Throughout this project, we created several different pages that address the data that we are provided, but for this demonstration, I'll only be taking you through the key points. Please note that for the safety of our client, some of the information will be hidden as they are confidential. In our project, our initial source of data was the executive survey. Providence provided this multi-question survey to all of its executives, addressing the performance of the information technology department. The aim was to get an overview of how well the department is performing as a whole. In this first page, you will see some of the key performance indicators that we have created from this survey. We received about 162 responses, and then we took the average scores for the following questions. How would you rate our service on a scale of 1 to 5? And on a scale of 1 to 5, do you feel that IS/IT knows and understands your business? The last aspect of this page is addressing the sentiment analysis that we did for one of the final questions. That question being, what aspect of our service are you least satisfied with and why? Admittedly, we have a lot more negative scores with this because um, they're directly asking the executives what aspects are they least satisfied with, meaning it'll most likely be negative answers. And there were only a few executives that didn't have any issues whatsoever. We only did the sentiment analysis on this question because the other questions were sort of just on a 1 to 5 score, whereas this question was more text data, which we were able to actually analyze. The second source of data for our project related to service tickets. We figured this would be a good way to kind of not branch off, but dive deeper from our initial analysis with the survey. We were basically provided a million row data set on tickets that IT has received in the past year. We decided to break it down to the most recent 3 months because we figured this was a way to dive deeper into some of the issues without going through all million rows. The top left visual is a bar chart breaking down the 5 most common issue categories. The most frequent issues arose from Active Directory, Kronos, issues with individual devices, end user device services, and Citrix. On the top right, you'll see some of the details about our findings. We analyzed 155,000 tickets in that 3 to 4 month span that I was mentioning, and then we took the average and the median of the resolve time. The resolve time in this scenario is basically how long it took from the ticket to be submitted to IT to the ticket to be resolved. In the bottom left, you will then see a word cloud on the description section of these tickets. You'll see that most of the tickets basically had the word caregiver, unable, user, and Epic in their description. Epic is basically this tool that is frequently used in Providence. The last aspect of this page is the contact type breakdown. 97% of the tickets were submitted through the phone, and then the last 3% were basically submitted through self-service, email, chat, alerts, and walk-in. This is kind of an important piece because we later talk about how it might be useful to use other services more frequently than just by submitting tickets through the phone. The last part of this demonstration is the CSAT score heat map. As requested by Providence, we were to create a proof of concept as to how we could address this demand for seeing in real time how their hospitals are doing. We decided to formulate a heat map and assign scores to regions in which Providence has hospital. In this proof of concept, we denote red as being a poor CSAT score and green as being a good CSAT score. Please note that this is just a proof of concept and we use dummy data for this, so the information doesn't actually reflect Providence's actual hospitals. Not all of it is red in this situation. Yeah, that basically wraps it up for the dashboard.
Thanks, Harbin. So I'm going to talk about our machine learning model that we created in Azure Machine Learning Studio. As we mentioned before, Providence is trying to improve their customer satisfaction. And one thing that was a recurring theme in the surveys that we were reading was that IS tickets were taking too long to get resolved. So our MSBA team set out to try and predict how long a specific ticket would take to get resolved. This pill here represents the data set that was given to us by Providence, and I'm not going to show you what it contains because it has some confidential information, but I'll briefly describe it. It has about 154,000 rows of data pertaining to various service tickets, as well as 55 variables, and this data spans 3 to 4 months in the year 2019. And a lot of those 55 variables were not deemed important to include in our model, and the way that we determined that was this pill here called the permutation feature importance pill. So if I click on that and visualize the results of it, it shows us the 9 variables that it deemed important to our model. The top one being who the ticket was assigned to. Another important one was the contact type, which could be phone, email, in person, or through their portal. And it also deemed the department and state in which the ticket was opened as important. We tried using different types of regressions, but we found that the boosted decision tree regression gave us the best results. And the way that we measured that is through this pill here, the evaluate model pill. It has different metrics here, but the one that we're most concerned with is the coefficient of determination, also often called the R-squared value, which in this case is about 70%, which indicates that this is a pretty good model that we're dealing with. But let's talk about the more exciting part, the deployment of our model. So Azure Machine Learning Studio deployed our model in Excel. And so note here that we have some blurred information. Again, it's confidential, but essentially it's some data that fills in these 9 variables that I was talking about earlier. And the really cool thing is that if I hit predict here, the deployment will actually predict how much time it's going to take for these specific tickets with these different attributes. Now I'm going to hand it off to Shilpa, and she's going to talk about our recommendations to Providence moving forward.
Our recommendations for Providence are split into 2 different categories. So the first category is regarding the KPIs, and then the second category is regarding the actual IT tickets. So first, for the tracking baseline KPIs, as we mentioned earlier, one of our tasks was to come up with KPIs that Providence could use to really measure how their IT satisfaction is changing. So one recommendation we have is that they should keep doing their surveys and integrating any new ones, but that these should be done on a yearly basis. So that way, as they're making changes to the system and improvements, they can track how these KPIs are changing and if they're actually having the intended impact. The other recommendation we have regarding the surveys is that we think they should be facilitated through some AI service, like maybe web apps, as opposed to being done in person. The second bucket of recommendations we have is for IT service ticket improvements. So Providence does already have a tracking system for IT tickets, of course, but we think they should implement more details into what they have currently. So right now it's pretty basic in terms of what they track, but having more details would be helpful in seeing more patterns and data and maybe which kinds of tickets are taking longer to solve. And then also based on the model that Patrick went into more detail about, we have identified some individuals who are better at closing tickets more quickly. So we think that combined with some additional data on the actual IT ticket, Providence could allocate their tickets to the person who's best capable of solving them. So that concludes our presentation. Thank you for listening.